What is a twin boundary? Twin boundary is a special type of the boundary grain. I mean, the grain boundaries have then, I mean, irregular fashion. There is no such a pattern. There is no such fashion. Okay, I mean, there could be anything like here in this way. It is a random. It is a random, grain boundaries. Like anything could be happen. Okay, so you can think about A boundary, sorry, A grain size, B, C, then D. Okay, so there is a B, C, D. Okay, so all are of different kind. Okay, so I mean, it could follow the any random, grain boundaries. Okay, but in twin, there is a perfect alignment. There is a perfect size. Okay, and that is here. You can see here. It is a twin boundary. As you can see, what the difference twin boundary has means the deviation in the surface is follow other some kind of the patterns. As you can see, this is your defect. This is again boundary. Okay, I mean you can see this is a boundary. This is the boundary, right? But before the boundary and after the boundary, there is a perfect kind of alignment. Okay, here it is the same as it was. I mean, the both the side you have the same structure, same pattern, and in between where the misalignment is there, they are also having this pattern. Though they are not following the same as it was here, but they are having this some pattern in their own. Okay, so here it is. This is known as twin boundary, twin grain boundary. As you can see here in this defect, you have the same left and right. Okay, grain, as you can see, grain fashion is here and here is the same. They are also in the same in the fashion, but they are not equal to this one and this one. So in this type, all are in their regular fashion, but for I mean where the defect is there, right and left, you can see all are in their equal fashion, but the dislocation are in itself in fashion, but not yet equal to the right and left. So this middle, if you can count it like, if suppose this is A, this is B, and this is C. So A and B are equal, okay, in their grain fashion, their grain um, placement. Okay, so they have the same grain arrangement. Okay, but if we talk about the C, they are not equal to the B and C, but in itself they are in a some fashion, some regular fashion. As you can see here, they have deviated from this boundary, right? But still they are in a regular fashion. Okay, so this kind of known as the twin boundary. Okay, so it is a kind of the special kind of, I mean, it is a subcategory of your grain boundaries. Basically, grain boundaries is a vague term, and under the grain boundary, there is a subcategory which is known as the twin boundary. Okay, so a special type of grain boundary with mirror symmetry. Mirror symmetry means, I mean, whatever it is here, that would be look like in there. I mean, just opposite to each other's. As you can see in this figure, this is like the mirror, and this is kind of the mirror. The same figure is here and here. This is the kind of the mirror. Okay, so mirror image. So this is behave like the mirror. Okay, atomic arrangement on one side of the boundary is mirror image of the other side. Simple, as I've shown you. Okay, mirror symmetry defects within the crystal and strengthen the material by by preventing the dislocation motion and strength the material. But what the kind of the differences is there, that it strengthen the material means the strength will not compromised. How? Because the dislocation is not able to move. If dislocation will be able to move from their position, it means you are compromising your strength. Though you could have more ductility in that case, okay, but strength will compromise. But in this uh, uh, you know condition, you are not basically having the less strength in that particular material where the twin boundary grain defect is there, because that will not provide, that will not let your grains to move from here to there. That's why your strength will not get compromised. Okay, so strength will be same as it was.